All right, so sometimes when you are trying to factor your polynomials, you run into something that looks like this, for example. X squared minus 25. And you might say to yourself, okay, well, let me see. Is there something I can factor out of the whole thing? No. There's no common factor that I could take out here. If there is, I still do it, always. If there's a common factor to take out, always, always, always take it out. Okay, but you might notice something about these two. First of all, let's break down the topic here. Factoring the difference, what's difference mean? Subtraction, right? So subtraction, oh look, I have subtraction here. So difference means subtraction, so you have to have that. Of 2, so I only have 2 terms here, that's important. Perfect squares. What in the world is a perfect square besides the shape? X squared is a perfect square. Give me numbers that are perfect squares. 4 is 9, 16, 25. Do you know where these numbers are coming from? 36. Yeah, your perfect squares. I'm just going to make a list over on the side here. Perfect squares. So, your smallest one is 0, but we're not going to worry about 0 because it's not going to help us. But to make my list of perfect squares, I just take each number and square it, and its answer we call a perfect square. So 1 squared is 1. So 1 is considered a perfect square. Why? Because its square root is a whole number. The next perfect square is 4. If you take the square root of 4, you get square root is 2. Yeah, 2 is a whole number, so 4 is also considered a perfect square. And then 9, is, the square root is 3, 16, 25. We're going to make a little list here. 36, 49, 64, 81, 100, 121, 144.
What about 125? I mean, no.
125 is 5 cubed.
Oh. Yeah, those
13 is 169, 14 is 196, and 15 is 225. So usually that's a good list to know, up to 15. Now, you don't have to memorize this list. It took me 10 seconds to just come up with it, and all I was doing was 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. But it's helpful to get used to these numbers. So when you see the number 49, it's ringing a bell in your head like, oh yeah, that's a perfect square. When you see 121, I want you thinking, oh yes, that's a perfect square. So it's helpful if you can quickly recognize them as perfect squares. Obviously there's more, right? They go on forever. So if we can at least familiarize ourselves with the first 15, that'll be helpful. So 25 is in fact a perfect square. What about x squared? Gianna said that that was a perfect square. How did you know that? Well, let me ask you this question. Is x to the third a perfect square? Is x to the fourth a perfect square? Is x to the fifth a perfect square? Is x to the sixth a perfect square? Apparently you guys have no idea. So here's how it works. Remember, if I take the square root of any of these numbers, it comes out to be a nice whole number, right? If I take, what do you guys think let me just ask you this. What is the square root of x squared? It's just x, right? Because x times x gets me x squared, right? Because x times x equals x squared. Yes, so the square root of x to the fourth is x squared, because x squared times x squared is x to the fourth, right? Now here's where I usually lose people. What's the square root of x to the sixth? X to the third. Because, again, x to the third times x to the third really is just x to the sixth. So in other words, ladies and gentlemen, any variable raised to an even exponent is a perfect square. I know it gets confusing because you're so used to these being your perfect squares. They are, but so are these variables being raised to even exponents. I know, like, this one trips you up because you're like, 6 isn't a perfect square. I know that. But that number right there is not 6. It's x to the sixth power, which is totally different. So, any, let's put a big old star, any variable raised to an even exponent is a perfect square. And you can tell by our little mini chart here, the square root is just half the number. So if I asked you, what's the square root of x to the 50th? X to the 25th, right? You just take half of it. So the square root of x to the 66th, 33. The square root of x to the 100th, 50th. You just take half for the exponents, okay? So there's a difference if I'm just talking about a number. If it's just a number, it's got to be my perfect square list. If it's a variable raised to an exponent, it just has to be even. And it's considered a perfect square. Am I making sense so far?
Yep.
Now, how to factor them is actually super, super, super easy. Once you recognize that you have the difference of two perfect squares. So, if I can just scoot over here, right? So, if I go back to my original problem, is x squared a perfect square? Yes, any variable raised to an even exponent is a perfect square. Is 25 a perfect square? Yeah, it's in my list. So, and I have the difference of the two, right? If that's a plus, you actually can't do anything. If it's a minus, though, now we're in business. Okay, you ready? You ready for how to split this up? You ready? Ready? It has to be a minus in between the two numbers. If it's a plus, you cannot do this. All right, so if I want to factor this puppy, I'm going to create two binomials, just like I have been. And here's the ticket. You ready? All you have to do is take the square root of each number and then make one a plus and one a minus. So, let me back up. Okay, what's the square root of x squared? That is your first term in each one. What is the square root of 25? 5. So 5 is your second number, and then all you do is make one of these a plus and one a minus. That's it. Miss Abia, there's no way that that works. Oh, isn't there? Let me check. If I foil these two back together, my claim is that I'll get right back there. Let's investigate. So here's me checking. Foil, first, x squared. Outside, minus 5x. Inside, plus 5x. Last, minus 25. Lo and behold, what happens with these two? They cancel each other out. A minus 5x and a plus 5x. By golly. I'm right back to where I started. So yes, this does work. And hopefully this explains why it has to be a minus in between the two. If you don't have a minus there, these two terms are never going to cancel out. That's why there is no such thing as factoring the sum of two perfect squares. You can't do it. It's a prime binomial, I guess, at that point. Okay, so let's try another one. Say I had x to the 6th minus 81. Yeah.
X to the third, both parentheses,
So, ask yourself, do I have the difference of two perfect squares before you even start? Is this a perfect square? Is this a perfect square? Am I minusing them? Is there anything I can take out of the whole thing? No. Okay. But if it's the difference of two perfect squares, just like Gianna said, I'm going to take the square root of x to the 6th, x to the 3rd. That's my first term in each. And then what's the square root of 81? 9. So one's a plus 9, one's a minus 9. That's it. Isn't that easy? Okay. I'm going to try and trick you. Ready? Or should I not trick you yet? I won't trick you yet. Everybody just try this one. Oh, I know what to do. All right. Try this. Yeah, let's do this. Try that one. But Masabia, 18's not a perfect square. Yeah, I know it is.
Oh, but you have to do the divide by 2.
You can take out a 2 here, so you should. If there's ever anything to take out, you gotta take it out first. And then see if you can go from there.
See your case.
Go super fast. Everybody's got an answer? Go ahead, Gianna.
2 and parentheses x minus 3 then parentheses x plus 3. Oh wait, and then the next part would be
Yeah. So first I'm going to take out a 2, and that's what's left, right? Now I realize, oh, hey, that in the parentheses is the difference of two perfect squares. So that's going to split up, and then this 2 just comes down for the ride. And these become x plus 3, x minus 3. Again, the order doesn't matter, so if you say x minus 3, x plus 3, who cares? You just need to have all 3 of these pieces. Not too bad, right? Ready for me to try and trick you? Okay, good. What if I gave you something like this? Is there anything to take out? No. Is it the difference of two perfect squares? It is. 100's a perfect square, and x to the 10th is a perfect square, and I have a minus, so I should be able to factor this. Let me give everybody a chance to guess. Write down what you think this would look like. All right, go ahead.
a negative x to the 5th plus 10.
And what's in the other one? So here's the thing. The x doesn't have to be in the, you just want whatever this number is, take its square root. So what's the square root of 100? 10. That's just going to go in your first spot. It's just whoever is the square root of this goes here. Whoever is the square root of this goes in the second spot. So what's the square root of x to the 10th? So one of them is a plus and one is a minus. So you weren't wrong. this is negative x to the fifth plus 10, but then the other one, you would have x to the fifth plus 10. So you can do it that way, but why bother? First number, just put in the first spot. Second number in the second spot. Okay. Ready to get super stumped? Oh, goody. Okay, let's try this one. Remember, I'm trying to stump you. Did everybody write down an answer? Raise your hand if you wrote down x squared plus 1 and x squared minus 1. Did anybody write down anything other than that? What'd you write?
Well, I didn't finish, but I was
Oh.
like x minus 1 times x plus 1 and then times, I don't know, I didn't finish.
Finish. I'll give you a second. Because you're right.
Don't put me on the spot, what? You're good.
So, you guys aren't wrong if you wrote this.
Because it can't be x squared, you have to factor.
You're not wrong if you wrote that. You're just not done. What are you talking about, crazy lady? Well, look at those factors. Do you notice anything about those factors? There's another difference in two perfect squares right there. So that one can get split up again. Isn't that, if I had just given you the original problem, x squared minus 1, isn't that the difference of two perfect squares? Right? You with me? So just that, x squared minus 1, that by itself would split into x plus 1, x minus 1. The square root of x squared is x, and the square root of 1 is 1. One's a plus, one's a minus. This just comes along for the ride. You can't split that one up anymore, because that's a plus. So this is your correct final answer.
But couldn't you do x, never mind, you're right.
You can have your pieces in any order. So you might have the x plus 1, x minus 1 in front. Whatever, you just need these three parts.
Wait, but I put x minus 1, x plus 1, x minus 1, and then x minus 1.
Oh, that's wrong then. I thought you were gonna, I was glad that you had these two.
How do we stand up first?
Yes, good. But the plus, you can't do anything with it because it's not the difference of two perfect squares. It has to be difference. So let's try another one. Maybe it's like this, maybe it's not. Who knows? Let's see. I'll have to think on it so I don't mess it up. Okay, I think this should work. Everybody try that one. Ow. All right, let me hear some answers. Gianna, go ahead. Okay. Any other answers? Everybody got this one? I don't believe you for a second. Everybody got that answer? Go ahead, Bridget.
It'd have to be x minus 2 and x plus 2 because it's squared.
So you mean those two should be 2's?
Yeah.
Let's see. X minus 2. I just want to write down all the answers you guys give me. Any other answers besides these two? You guys are such... I don't believe you for a second. Go ahead.
Right. I got 4 and then in parentheses x squared minus 16. And then the other set of parentheses x squared plus.
Okay. What else is out there?
I got the second.
Go ahead. Go ahead. That's all right.
2 parentheses x squared minus 8.
X squared plus 8. Any other, oh sorry, any other answers that are out there? All right, so unfortunately they can't all be right. So first thing we should always do, factor out anything we can. So is there a common factor I could take out from the beginning? 4. So we should take out 4 from the very beginning. And I get there. Is everybody in agreement so far? All right. So this 4 is just going to stay with me until the end. That's part of my answer. This x to the 4th minus 16, that is the difference of two perfect squares. So I should split that up. So this 4 is just going to come down, and then I'm going to split this up. What is the square root of x to the 4th? X squared. So that's my first term in each. And the square root of 16? 4. So one's a plus 4, one's a minus 4. Now, that I can't touch because it's a plus, x squared plus 4. There's nothing for me to do there. Same thing, there's nothing for me to do with this 4 that already came out. So these two pieces are just going to keep coming down as part of my answer. This, however, is the difference of two perfect squares. I can take the square root of x squared and I can take the square root of 4. So that one's going to split up, whereas these two just come along for the ride. So they're there, and now this one splits again. Square root of x squared is x. Square root of 4 is, what's the square root of 4? 2. So one's a plus 2, one's a minus 2. Can we go any further? There's nothing to do with just a 4. We already said that that's the sum of two squares, so I can't touch it. And then those aren't squares at all, so they're done. This is my final answer, which is the same as this one here, right? The second one. Okay, be careful. You. All right. So that's the, oh, you know what? Let's try a really tough problem. You can have more than one variable too. Let's just stick them all on there. Say I gave you something like 16 x to the 10th y to the 30th minus, oh, I don't know, how about 25 z to the 12th? It looks awful, but it's not that bad. Are these perfect squares? Is that a perfect square?
Yes.
And I have the difference, so I can split this up into two different ones. Just be careful. What is the square root of this first term? 4 x to the 5th, y to the 15th. So that's my first one. Doesn't matter if it's an exponent, it just has to be even. So, and then I just need the square root of this, 5z to the 6. So one's a plus 5z to the 6th, one's a minus 5z to the 6th. Can you keep going? Do either of these split again?
Yes.
Nope.
Yeah.
Well, that one's a plus, so you can't touch it anyway. This one's a minus. Is this a perfect square?
Yeah.
Yeah. No.
4 is, but these are odd exponents. Odd exponents are not perfect squares. And even over here, 5's not a perfect square, so you're done. That's the best you can do with that one. But do you see how bad it looked in the beginning? But then once you do it, it's really not so bad. Right? You just take the square root of the numbers, and you just take half the exponents. Half the exponents is the square root of the exponents. Any questions on the difference of two perfect squares? No? Alrighty.